Let's talk about the definition of a strong acid or a strong base. What makes an acid strong or weak? To do this, we're going to look at the Ka table on the back of the notes. Ka stands for equilibrium constant for an acid. And the size of the Ka value will tell you the strength of the acid. Strong acids have large Ka values, and likewise, strong bases will have large Kb values. Kb for equilibrium constants for a base. So let's look at that table. We have a general equilibrium for an acid here at the top. We have Ha representing an acid. That would be in its molecule form. The molecule will split into ions, one of those ions being H+, which is the definition of an acid, a proton donor. If we wrote the equilibrium expression for this acid, we would get products over reactants, concentration of H+ times the concentration of I-, the ions, divided by the concentration of the acid, the molecules. So if you have acids that have very large Ka values, what does that mean? It means you have a larger numerator and a smaller denominator. You have more ions, less molecules, which means more H+, which is the definition of an acid. So strong acids will dissolve almost completely to form H+ and A- ions. So you can see on the table that we go from very large Ka values all the way down, -2, -3, -4, and if you keep going down, you'd get all the way down to -14th, -36th. So when we get down to those small K values, we end up getting acids that don't dissolve very much. They don't split up into ions. So to summarize that, a large Ka greater than 1 means products are favored. You get more ions, more H+. A Ka less than 1 means reactants are favored. You have more molecules. You have less H+ in solution. Remember, H+ is the definition of an acid. So I think this is better seen with a diagram. So here we have a strong acid, both concentrated and dilute. In the concentrated version, you can see a whole heck of a lot of H+, but not very much weak acid, Ha molecules. Way more ions, way less molecules. This would have a Ka greater than 1. Lots of ions, only a few molecules. You can see if we just diluted it, we'd have the same thing. We'd still have way more ions, but even less molecules now. If you look at a weak acid, the exact opposite is true. We have more molecules than we have ions. If that's the case, we have more reactants than we do products, and the Ka will be less than 1 because there's way more molecules and way less ions. You can see this in both the concentrated example and the dilute example. More molecules, less ions. Let's do a few sample problems with strong acids and bases. So what's the pH of a 5.0 times 10 to the negative second molar HCl solution? If you look up the Ka value for HCl on the table, it's going to say very large. That means it is a strong acid. So what we can assume at equilibrium, there will be no molecules. It's a very safe assumption that there are hardly any molecules at equilibrium, and we are going to have all ions. Now, since a molecule of HCl breaks up into one H+ and one Cl-, whatever the concentration of the acid is given in the problem, that's going to be the concentration of H+ and the concentration of Cl-. But we only really care about the concentration of H+ when determining the pH. So for a strong acid, you want to know the pH, just take the negative log of the concentration. So negative log of 5.0 times 10 to the negative second is 1.30. Well, how about a strong base? NaOH is a strong base. Same deal, but we have a couple extra steps because we have OH- instead of H+. We can assume this is going to dissolve completely into ions. So we have no NaOH molecules, And the concentration given to us will give us the concentration of Na plus and the concentration of OH minus, since NaOH will split up into Na plus and OH minus. So we can get the pOH instead of the pH by taking the negative log of the OH minus concentration. So that ends up being 2.7. And then to get the pH, we can use pH plus pOH equals 14. So 14 minus the pOH will get me the pH. So I get a pH of 11.3. So now it's your turn to try a couple examples like the ones I just did here. You're given the concentrations of a strong acid and a strong base. You need to determine the pH. Pause the video, try them out. When you think you got it, press play to see the solutions worked out.